Sydney and I make an announcement
Of
about
course.
today or this week's
Yeah.
change in schedule?
Yeah, sure. How is everyone doing today? Good? Okay, I'll wait like 2 more minutes before I start the lecture, so it would be like 12:30. So today we have like our 14th lecture, and this is like 14th of February. I thought it's just cool coincidence. And your SI Pass leaders have like announcements to make. So I just wait for like 12:30 exactly, so they make the announcements. And you guys have your exam on this Friday, which is in person. So your homeworks and quizzes are online through Canvas, but your exams are in person. So make sure that you know that. And if you cannot make it to the in-person exam for an excused reason, make sure to communicate that with me in advance. And as you saw in the course syllabus and course schedule, I require that you provide me with like a letter from your academic advisor if you have like field trip or something related to university, if you have like athletic event or for any excuse reason, or if you're sick. So make sure to communicate that with me in advance. Does that make sense? Okay, it's 12:30 now, so I start with the SI Pass leaders, so they make the announcement about the SI Pass.
Hi everyone. So there's a change in schedule just for this week to accommodate for your exam on Friday. So my session today will still be the same time, but tomorrow it's from 4 to 5:50 instead, and it'll be in room 148 in the TLC, and that will just be specifically over content for the exam, and I'm going to have like a practice quiz and a few other things to help you study.
And then mine are kind of the same. I have my regular one on Tuesday, and then I have an extended one on Wednesday from 4 to 4:50. That one's in the education building in room 441. And same thing, that session will all be reviewed for the exam, and then I'll have no session on Thursday.
And also, please note that my session on Wednesday will not happen, and Sydney's session on Thursday will not happen because we're holding the extended session
first part, the last part, you can do that too. So yeah, thank you guys.
Okay, thank you guys. And I'm also writing them here for people at home. So the last one is 80. What is it?
Yes.
80. Okay. 441. Are these correct? The ones that I wrote on the. Can you confirm?
Yes.
Okay. And I also had, sometimes the students talk with me, about like SI class, or they have concerns that if they go to SI class, it means that they didn't learn the material or whatever. So these sessions are for you, and whether or not you know the course materials, I encourage you to attend. And most of the times, and that was the case my last semester, and also for tutoring for my other course, that students that go to the sessions, there are students, that end up with better grades. So don't feel that, you shouldn't show up to SI class, or like you shouldn't go to tutoring. You should take advantage of all the opportunities provided for you. Does that make sense? It's as if you say that if I show up to the class, it means that I don't know the material. Nobody expects you to know the materials before coming to the class, right? And your SI class leader is also here to help you. And sometimes I explain something, but it's kind of like a significant figures decision that I was struggling, to demonstrate the point. But your SI class leaders, might explain it much better than how I do it. So I encourage all of you to attend, especially this week you have like your exam, and I give your SI class leaders your exam, so they solve really similar questions that you're going to see on the exam. So it's just like extra resources for you, and I encourage you to attend as much as you can. Does that make sense? And the sessions are anonymous, so you don't have to worry about anything. I won't know who attended, who didn't, but I encourage you to attend for the sake of learning. Okay? And if you cannot make it to any of the sessions and you want extra help, just, you can schedule tutoring, but feel free to just reach out to me. And I tried my best to communicate that with you, that I'm here any time of the day or night. If you have like, 2 jobs, and then you have like several courses, and then you cannot make it during any conventional time, just email me. I schedule some time that works for you to have like a tutoring session with you, because I just want you all to succeed. And sometimes, now I'm kind of like going off the lecture, kind of just chatting with you, but sometimes I have like, when I have concerns about my students, and I tell my colleagues, sometimes some of them say that, you should just like do what you're supposed to do, and if they don't want to study, it's not your fault, or like you shouldn't feel bad. But I genuinely care about each and every one of you, and I want to make sure that you succeed. And as long as you communicate that with me, I make sure that happens. So anytime that you have difficulty with the course, anything, just contact me. I make sure that you understand the materials well and do well on your exam. Does that make sense? Okay, so let's start the lecture. So I start with something that one of your friends asked last session about Q. That why do we show heat with the symbol Q? So I never thought of it, to be honest, after these many years of showing, writing Q as a heat. And I Googled it and then found this like scientific paper that says, why do we symbolize heat with Q? And the reason is that, and I included everything because I thought this is kind of like also cool to show you how to refer to scientific literature when you're looking for an answer. But the short answer is that because, the first time that when the scientists, or here, specifically Clapeyron, when he was showing heat, he referred to it as quantity of heat. So basically, this is why we show, or like symbolize heat with Q. So I thought to just like include that, because I thought it's like Cool, and you're welcome to just read the article, or at least the part that I included here as well. So, and I also have like the link to it if you want to just find the article itself. You can get access to this article through University of Idaho library, so it's not open access. Anyway, any questions? And again, remember that anytime during the lecture, if you have a question, just raise your hand. Or, sometimes, I have a mask, and it may be hard to hear what I'm saying, or like maybe hard to understand what I'm saying, So just like don't, feel free to just like ask me anytime. And the same thing if I'm writing something and you cannot read that. Okay, so we're going to start chapter 4, and your exam 1 on Friday would be about anything that we learn by the end of the day on Wednesday. So pay attention to the lectures, and these would be on your exam as well. But your quiz too, I'm going to post today, it would be up to the materials that we learned today. So you technically can answer the questions after the class. Does that make sense? And again, if you anytime have any question about the course, just like feel free to reach out to me. So now we want to talk about atoms and elements. We talked about atoms and elements in the previous chapters too. Can anyone tell me what was an element? Anyone? What is an element? Yes?
It's a substance that can't be broken down to any further substance.
Exactly. So element is a substance that cannot be broken down, simpler substances, right? And remember that we had like all the elements listed in the periodic table of elements, and I told you this is kind of like the alphabet of what we're learning in this course, and these are really important. And here, I kind of like deleted the section for like mixtures, because now I want to focus on like elements and atoms. And again, kind of like, remember these definitions, you're going to see them in the exam. But in general, as your friend mentioned, element cannot be broken down to simpler substances. And can anyone tell me what was a compound? Just read it from the board or the screen. Yes?
The substance composed of two or more elements in fixed definite proportions.
Exactly. So if we have a compound like water, H2O, the proportion of like hydrogen and oxygen is the same. Always 2 hydrogen for every oxygen. Okay? So, and we talked about periodic table of elements, and this, I'm going to give you at least 2-3 questions of periodic table. And I give you an element in your exam, sulfur. I say, what is the group and period of sulfur? So can anyone tell me what is its group number? Exactly. Yes. What is, or you can say 16, depending on what I give you in the options. So what is the period number or row number? Exactly. You go here and then write this number. So if I tell you, for instance, argon, what would be the group number? 8A, right? Remember, these are, maybe I use the highlighter. These are groups or families. They are like vertical lines, okay? But periods are like horizontal lines. Does that make sense? Okay, can anyone tell me what metals we studied last session and I asked you guys to remember? Yes? Exactly. So remember, those are in group 2A or 2. Beryllium, and we said like magnesium and calcium, we heard that in our daily lives too, right? So now today I'm going to ask you guys to remember strontium barium, radium. Okay? So just remember them. Yes?
What would a question on the exam for those be like? Would it be like BCPE? We should know that that's beryllium.
I give you, yes, so you should know the abbreviations as well, yes. But I'm going to tell you that which are, and you saw, I already asked you your homework problems too. I said which of the following elements does not belong in group 2A, or like which of the following elements does not belong in the same group as the others. And I gave you like, for instance, lithium, magnesium, calcium, radium. And then you know that, okay, all of them were like group 2A, but lithium is group 1A. Or I asked you which of the following is not a metal? Hydrogen, lithium, sodium, potassium. And you remember hydrogen is a gas, right? So, yeah, so today I added like 3 more metals, and hopefully, you can just like remember these. Any questions? So right now, you should know groups 1A, and remember, yes?
Sorry, so when you refer to groups, you're referring to families, right? They're
Exactly.
Okay.
Yes, groups are the same as families, periods are the same as rows. So if you have like horizontal line, these ones are like rows, kind of like this. And these ones are like families or groups. And the reason that we call them families is that they have the same characteristics. So they are like the same groups or the same families. Great question. Any other questions? Good? Okay, so you're going to see two types of questions this Friday. One would be I give you an element and I ask you which group and row number it belongs to, and I give you the periodic table of elements for that question, so you don't have to worry about that. I don't expect you right now to know all these elements because I didn't cover them all. But for the other ones, these metals here, I expect you to kind of like have familiarity with them and can like distinguish them from one another. And knowing that all elements in groups 1 and A are metals except hydrogen, which is a gas. Good? Okay. 7A, they exist as like diatomic molecules, meaning that we have like F2 most of the time, not F by itself, or like we have Cl2. We have like molecules which are composed of 2 atoms, which we call diatomic molecules. And we are going to talk in more detail as we progress with the course. So right now you don't have to worry. It's kind of interesting that when I was studying periodic table like years ago, we didn't have like this last row here. I mean, we had like francium, but here, let me just change my color here. These elements at the time, or at least these ones I'm sure, like because we had to remember these main group elements, so these didn't exist at the time. And so this is kind of like the point that I was mentioning, that there are like discrepancy between like how many naturally occurring elements we have, how many man-made. So in your exam, I'm just, ask something really straightforward. I don't give you anything that you get confused over that. But I noticed that myself too, that the numbers that I had in the previous lecture does not match with this one. This is what you're asking, right? The naturally occurring elements, right? Am I addressing that? Yes, so you don't have to worry about in your exam, as long as you know that, we have elements listed in the periodic table of elements, and some of them are like naturally occurring, most of them, and some of them are like synthetically made, or they are like man-made, they don't exist in nature, you're fine. So don't worry about that for your exam. Great question, great catch. Any other questions? If no question, I'm going to start with like different sections of chapter 1. It's chapter 4, section 1. So The first part is like experiencing atoms at Moscow. So basically, in everyday life, we're experiencing atoms. And I kind of like, included a picture of Starbucks at University of Idaho to make this like more interesting and kind of like having like a beautiful picture of Moscow here. So when you have like, experience wind, you have like, oxygen and nitrogen, you have like air. When you're just like drinking water, when you're drinking coffee, or when you, anything that we interact with. Again, we said that anything that we can see virtually or anything that has a mass and occupies a space, all of them are like matter, right? So we're just dealing with atoms all the time without even thinking about it. So all matter composed of atoms. Atoms are building block of matter. Remember, we had like this definition from the very first day. So we experience atoms all the time. Any questions? Group. Okay. And the one thing that is really important is to know how small atoms are, and to kind of give you a sense of how small atoms are. Your book gives an example of a pebble, that if you consider a small pebble, and that pebble is composed of atoms, okay? So if you imagine each of the atoms in this pebble being the size of the pebble itself, that pebble would be the size of and even bigger than Mount Everest. So you see how small atoms are. This is kind of like, really, I mean, if you think about it, it's just like mind-blowing that how small atoms are, right? Is that clear? So I'm going to ask this, true or false, in your exam, or say like which of the following sentences is not correct. And if you don't know this, probably you'll think that this sentence doesn't make sense, but it does because atoms are so small. Any questions? Good. Element in what I want. Okay. And after like each slide that I have just only an image, I also write down everything to make sure that you know them. And also, as I said, I'm going to ask like these in your exam. And I also post study guides, And the other thing that I wanted to clarify and make sure everyone knows, anytime that you have like an exam, or quiz or homework, I post the solutions on Canvas, and you should see everything on their modules. So, sometimes the students email me that we don't see our solutions, so I don't know how I did on the homework, or I want to see the solutions. I post the solutions. But if you want to specifically see your own solutions, also email me. I send you your solutions too. So you have all the resources to succeed in the course. And I post study guides that also include things in the slides to make sure that you know these things and you are aware of this. Yes?
So I noticed this on my different Canvas thing, but she had it where you could take the quiz and it shows you the wrong answers, but it doesn't show you the right answers. Are you able to do that?
I am able to do that, but intentionally I'm not doing that, because if I show you the right answer after you complete the question, sometimes the students will be tempted to give other students the right answer. And
Yeah, so what I'm saying, it only shows you the answers that you got wrong. Like it said, you got this question wrong, but it doesn't show you the actual answer. And so I think maybe some other people might agree, like, I want to know what questions I got wrong without having to know the
you can just email me, and even if all of you guys email me individually, I'll send you your, the whole quiz or like homework. So feel free to reach out to me. I understand, that sometimes the students want to see exactly how they did, and I send you after the deadline of the quiz or homework is passed, I send you the solutions, and that is a valid, really reasonable request. But as I said, I just want to minimize cheating in the homeworks and quizzes, so every person's grade reflects their own work. So that's why I provide minimal feedback after you complete the homeworks and quizzes. But I gladly share with you after the deadline and after I post the solutions. As I said, even if all of you email me that you want to see your own work, because sometimes you know how you answered the question, or you just kind of like answer the question and then compare with what I posted. But sometimes, maybe students forget what I answered or like confused about the grades, So feel free to reach out to me anytime. That's the bottom line. Okay, thank you for mentioning that. Okay, so atoms are the foundation of our universe because all matter is composed of atoms. And as we said, atoms are fundamental building block of everything we hear, feel, see, and experience. So instead of, I will give this blank to you and I say which of the following is a fundamental building block. And I say, element, compound, pure substance, energy, and it would be atoms, okay? Atoms, again, this is kind of like the same thing, just like different sentence. They are the basic units from which nature builds. And again, I include all of these things so you hear them, when you see them in the exam, they won't be like brand new information. Does that make sense? And atoms are incredibly small. The key to connecting the sub-microscopic world with the macroscopic world is the atom. Is that clear? Good? And atoms compose matter. The properties of atoms determine the properties of matter. This is also an important point, that the way that we feel things, experience things, hear things, all of those things are because of the properties of the atoms that constitute and form the matter. Any questions so far? Very good. I want you to, okay. And again, atom is the smallest identifiable unit of an element. I give you this and then have like atom blank. And I say, which of the following, fill in the blank with the correct word. And I say atom, molecule, ion, as long as you know atom, you will be fine. And this is kind of like definition of element that we went through. And we have like 91 different elements in nature. And subsequently, we have like 91 different types of atoms. So don't confuse the concept of element and atom. We have like elements in the periodic table, as you can see here, and all of these elements themselves are composed of atoms. Okay? So when we have like aluminum element is composed of aluminum atoms. It's not composed of beryllium atoms. Does that make sense? Okay, and we also have like over 20 synthetic elements that are not found in nature. And there are like some discrepancy between like number of man-made elements. There are some scientists, they argue that some of the elements that we claim they are man-made, they can be found in nature in small quantities. So just be aware of that. But in general, these are like, roughly the number of man-made elements. And many atoms exist not as free particles, but as groups of atoms bound together to form molecules, right? Kind of like, for instance, oxygen, most of the time, we have oxygen molecule, we have O2. We just don't have one oxygen atom by itself. Or when we progress with the course, I'll tell you that most understand what this sentence means. Is that clear what it means? Good. Nevertheless, all matter is ultimately composed of atoms. Any questions so far? Are we good with lecture so far? So, okay, now we go to the fun part. I guess now I had like so many, text written over there, but now I kind of like have some pictures. And your book didn't include the picture of the scientists. and chemists, physicists, but I feel like it's kind of like cool to visualize, the people that we're talking about, and maybe it helps you to understand the materials that I'm going to talk about as well. So now, we talked about atoms. We said that everything that we see, they are composed of, all matter, they are composed of atoms. But, what is an atom? I mean, we know that there are building blocks of all matter. There are like, smallest identifiable unit. All the properties that matter has is because of the atoms that they consist of. But what are they themselves composed of other things, or like is it like they have like we cannot divide them to simpler constituents? So this is like the whole purpose of this part of the course, that we want to know more about atom. So first we start with like the atomic theory. That basically atomic theory states that atoms are indivisible, meaning that scientists for the longest time, they believe that if you have an atom, that's it. We cannot break down atom, to other things, or rather, they don't have any constituents themselves. Basically, we cannot divide them to anything. And I kind of like had the timeline here too. So we had like Democritus and Leucippus, that they were like, ancient Greek philosophers. Like you see that it was like 460 before Christ. Like it was like long back in history. And Leucippus, they say probably it was like the time that he lived. They don't have like a certain time. But these Greek philosophers believed that we cannot break down elements, and they don't have any other constituents themselves. Basically, they believed atom is indivisible. Okay? And long after them, John Dalton, which, who lived like, in the 18th, 19th century, like these years that I listed here, your book listed, he also said the same thing, but, it was kind of like, it wasn't established. When the Greek philosophers said atom is indivisible, it wasn't as established when Dalton said. So don't ask me why, but this is how it is written in history, that he came up with atomic theory, although Democritus and Leucippus said the same thing. So the atomic theory, we say atomic theory of John Dalton, because he kind of established that. Does that make sense? What I'm saying? So I'll ask you that in the exam, that who believed atom is indivisible? And I say John Dalton, Leucippus, Democritus, Rutherford. And next slides, in the next few slides, I'm going to talk about him. But you should know that these three people believe atom is indivisible, meaning that atoms don't have any constituents themselves. Is that clear what I'm saying? Okay. So what I just told you, I just wrote here. Again, because I want to make sure that you have like all the text you need for your homeworks, quizzes, and exams. Okay? So Democritus is the first person that postulated that matter was composed of atoms. Okay? And again, Leucippus, Democritus theorized that matter was ultimately composed of small, indivisible particles. And Democritus suggested that if you divided matter into smaller and smaller pieces, you would eventually end up with tiny, indestructible particles called atomos or atoms. So this is kind of like the Greek version of it. The word atomos means indivisible. Is that clear? Okay. the idea of Leucippus and Democritus were not widely accepted. It was not until, 1808, over 2,000 years later, that John Dalton formalized the theory of atoms that gained broad acceptance. So, for whatever reason, the politics or whatever, this is how it is in history. That the atomic, kind of like Dalton formalized the atomic theory, which basically atoms are like indivisible. So Dalton's atomic theory has 3 parts, and I expect you to listen to this really well. Each element is composed of tiny, indestructible particles called atoms. The same thing that we mentioned before, okay? All atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. Kind of what I mentioned, that if I have like a phosphorus atom, an aluminum atom, they are different, and all the aluminum atoms, they have similar properties. Does that make sense? I mean, if it wasn't like this, it was strange, right? If you had like aluminum atoms and one aluminum atom was like heavier than the other one, I mean, it would be like kind of strange, right? Or maybe it wasn't. Anyway, atoms combine in simple whole number ratios to form compounds. For instance, if you have like H2O, we cannot have like H2.5O. We cannot it's kind of like you can think of it as like, they are like exact numbers, right? Think of them as like, people, the example that I made before, we can have like 100 or 101 students in the class. We cannot have like 100.5. It's the same as atoms. We cannot have like 2.5 atoms, whether we have 2 or we have 3. Does that make sense? So I'm going to ask that in your exam, and I say which of the following is not consistent with John Dalton's theory of atoms. And then I give you, that we can have a compound with like this, formula. So is this consistent or not? It's not, right? Because atoms combine in simple whole number ratios to form compounds. Okay? Any questions so far? Are we following the lecture? Okay. Now we want to talk about nuclear atoms. So as you may guess, based on the progress of the course and based on how I'm organizing the lecture, probably the fact that atoms are indivisible and indestructible is not correct. Atoms have constituents themselves. And now we want to see what are those constituents, and if they have constituents, how are they located in an atom? Does that make sense, the overall aim of this section? Okay, so we had like, Thomson, and again, like kind of between 1856 and like 1940, that he came up with plum pudding model. Is this how you say pudding? Pudding? Plum pudding model. I don't know, I was always saying pudding. You also say it in Farsi, pudding. I don't know, sometimes I feel like I should just like go, out of my way to make the word be pronounced correctly. Anyway, so plum pudding model. And it means that it's kind of like a blueberry muffin. So he discovered that based on some experiments that we're not going to study in this course, he realized that one atom has constituents. It has a part with, some constituents that have negative charge. And since atoms are neutral, he realized that it should also have constituents with positive charge. So he hypothesized that we have like, and after doing experiments in the laboratory, he theorized that we have like these, maybe I show it with like blue. We have like these negatively charged particles in a positively charged sphere, and he called these electrons. Is that clear? Any questions? So we have a sphere of positive charge, and we have like these electrons that they have negative charge distributed in this, positively charged sphere. And he came up with plum pudding model. Any question about this? I always ask this in the exam, and 90% of students get it wrong. So remember that electrons, they have negative charge. And this sphere, the whole, you see the pink, or like what color do you see that sphere, like pink? That is positively charged. Charged. Okay, any questions? Here. Now, everything that I just said, I included in a text, so it would be easier for you to study, because I feel like it's just like easier when you want to refer to the notes compared to just like pause the video of me talking, or kind of like, maybe it's easier than referring to your book. So again, I just go through it really quick and highlight important things. So matter was composed of atoms, the permanent indestructible building blocks of which all substances are constructed. However, an English physicist named J.J. Thomson complicated the picture by discovering an even smaller and more fundamental particle called electron. And remember, electron is the one that has negative charge, and it's kind of like, blueberries in blueberry muffin. Okay? Thomson discovered that electrons are negatively charged, that they are much smaller and lighter than atoms. So remember, they are really small, they are really light. And that they are uniformly present in many different kinds of substances. His experiments proved that basically the indestructible building block that we called atoms, they are basically can be chipped. Okay? The discovery of negatively charged particles now made scientists believe that we should also have positively charged, because matter as themselves, they don't have charge, right? I mean, we have like some matter that they have charge, but in general, things that we deal with in our everyday lives, they are like, they don't have a charge. That's right. So here, basically, they realized that we should have like positive charges too, so they balance each other, because atoms are known to be charge neutral. Okay, and now they realize, okay, now how should we have them fit together? And Thomson proposed that the negatively charged electrons were small particles held within a positively charged sphere. This model, the most popular of the time, became known as the plum pudding model. Okay, and your book kind of like, because this is like an English dessert, your book wants you to kind of know the equivalent of American desserts, so they have like here like the blueberry muffin. And this is kind of like interesting, because when I studied this like years ago, we have like these cookies in Iran that we call them raisin cookies. That base of it, basically we have like this solid oil that we make lots of cookies with. It's basically like butter, really unhealthy, but it's just basically we're eating butter. Anyway, that is like we put raisins in it, and you see like cookies that they have like it's kind of like blueberry muffin, but it's like kind of like thinner and it has raisins in it. So we have the equivalent of like raisin cookies. So depending on which country people teach this, they kind of like change the plum pudding model based on like what they have available. So as long as you know that whether like raisins or blueberry or like any kind of dessert, those ones are electrons and the whole sphere is like positively charged, you're good. Any questions so far? Yes?
How do they find like electrons? Like how did he see that they exist?
So that's a really good question. So I don't remember off the top of my head, but I'll look through it and then update you and kind of like the cue that I research and then update it you at the beginning of the class. I'll kind of like go through the history a little more. So great question though. Any other questions? Yes.
Our notes from like a couple weeks ago said there's 92 naturally occurring elements. In a couple slides it says 91.
Oh yes, actually I noticed that myself too. So we have like 118 elements in the periodic table right now, and something that I just wanted to share. Okay, so now we want to study the next model, which is like Rutherford model, the nuclear atom. And again, another experiment, Rutherford was like student of Thomson, and he was doing some experiments in the lab to validate plum pudding model, and instead of validating his professor's results, he contradicted those. And he realized that the plum pudding model is not correct. And again, you have like that experiment you have listed in your book, but I'm not going to ask about it in the exam, so you don't have to know the specifics. But if you're interested, I can kind of talk about that, briefly in the beginning of the next session too. But the bottom line is that he realized that we have like positively, which color? Maybe I'll use blue. We have like a nucleus in the center of an atom, so it's not like a sphere, it's like a concentrated positive charge in the middle of the atom, basically kind of like nucleus, and it has the most mass or weight of the atom. And we have electrons around it, which are much lighter, and kind of like compared to nucleus, they don't have any weight. They are really, really light. And this is kind of like exaggeration. If you want to show it like in more accurate scale, it would be like you have like the positive nucleus here, or maybe I just like erase this one. I kind of like, you have like positively charged nucleus, and then you have electron around it. So it's kind of like you have like much, unoccupied space. Does that make sense? Here is the picture that your book provided, that you have like the nucleus here in the center, and nuclear model volume of atom is mostly empty space. That's what I was trying to depict in the last image, that you have like positively charged nucleus that is really heavy compared to the electrons, and then most of the space, it's kind of like empty. And you have like electrons around the nucleus. Is that clear so far? Any questions? Okay, so when next session I go through this to kind of like make sure that you understood this well. So let's do the attendance so I make sure everyone gets credit for that. And make sure to just do the attendance right now, not after the class. And one thing that one of your friends mentioned last session, And I think it's really smart that he brought that to my attention. So if you put like the letters, small or, kind of like big letters, it's different. So sometimes, maybe when your link doesn't work, it's because like instead of like, capital N, you put like, lowercase n. So if you just enter it as it is, like probably it will work. But if it doesn't, just raise your hand so I come to you and you get credit for attendance. Does that make sense? It.